Okay, good day everyone. So this would be an updated uh, video lecture for loops and iteration. Okay, so loops are essentially repeated steps in programming. Okay, now usually a loops would have iteration variables that change each time through a loop. Now oftentimes these iteration variables go through a sequence of numbers. So for example, in this program, okay, in this sample program, we should essentially count down, okay, from 5 to 1. Then print the word blast off, then this 0 here. Okay, so this n here serves as our iteration variable. Okay, so let's write this into our code. So n is equal to 5 while n is greater than 0, print n is equal to n minus 1, print blast off, then print n. Okay, now first things first, similar to conditional statements, okay, indentation is very important in our loops. Okay, this means that this set of statements, okay, under that same indentation belongs to this uh, while loop here. Okay, it's very important that you get to recognize that there is, okay, there is an indentation there, meaning this statement here, even if we place it there, these statements here, okay, so lines 5 and 6, okay, are statements that are outside of this loop here. Okay, so what is this iterating variable? Now n here serves as our iterating variable, meaning every time the loops iterate, okay, when we say iteration, okay, that refers to the current execution of that loop. Okay, so this is the uh, per loop. Okay, there are many iterations. Okay, so on the first iteration, okay, let's say in the first line we assign the value of 5 to the variable n. Now here it's similar to a test condition in which it would test if this is true. Okay, now since this is a loop, while, okay, while this is true, okay, if this evaluates to true, then it gets to perform this. Okay, so on the first iteration, okay, on the first repetition of this loop, okay, so we have n is equal to 5, then what is the current value of n here? Okay, the value of n here, okay, I will write here the current value of n is 5. Okay, it's correct. So that is the last, most recent assignment of our value to this variable. Okay, now since this is true, 5 is greater than 0, it gets to print this. So let's say we have here an output. Okay, so on the first iteration, this is true, then this gets to be executed. Okay, then it would print n. Okay, so it would print 5. Next is this statement. Okay, what this will do is, I think you already know this, okay, you update the value of n by reducing the current value of n by 1. Okay, so n minus 1 is equal to 4. Okay, so it's equal to 4. After that, in every looping statement, okay, after the last statement under that loop is executed, it would check, it would go back here. That's why it's called a loop. It would go back here to check if this test condition is true. Okay, now what is the current, or what is the value of n at this second iteration? Okay, that is 4, diba? Since it has been updated here. So since 4 is still greater than 0, it gets to execute this. So we have 4. Then this statement would be executed. Okay, so 4, minus 1 is being assigned to this variable here. So we have the value of 3. Then it would loop back. So now the current value of n is 3. Okay? Since 3 is still greater than 0, we're going to print that. So we're going to perform this statement. Okay, so we print this first. So we have 3. Then again, we perform this operation, okay, which is 3 minus 1 is equal to 2 assigned to this value here. Okay, so the value of n at this line is now 2. So going back to the first, to our while condition here, okay, since 2 is still greater than 0, so now we have the value of n 2 here. Since this is still true, let's print this, okay, then perform this statement next. Okay, so 2 minus 1 is 1. Okay, and that will be assigned to this variable here. Going back, check if this is still true. Okay, so is 1. So we have here 1. So is 1 greater than 0, which is still true. So it's going to print this. Okay, 1. Then perform this step. So at this point, the value of n is 0. Okay, next is, okay, it would not stop there. Okay, while loop would start by a test condition and end with a test condition. Okay, so meaning upon the beginning of the loop, okay, it gets to check this. At the end of the loop, it would, okay, at this point, since this is our last statement in our loop, it would go back here to check. Now, since 0 is no longer greater than 0, okay, so it ended by testing if this is true or false. Since this is false, then it gets to proceed with the statements outside of our loop. Okay, which is at our line 5 here, it's going to print the word blast off. Then it would print the value of n, which is the latest value of n is equal to 0. That's why we have here, we would expect this type of output. So if you're going to run this, okay, you'll see that is the case. Okay, so that is our while loop. It's very important. Okay, aside from the indentation, loops should have a means of ending programmatically. Okay, you'll know that this would end since ultimately there comes a point in which this test condition is false would become false, since in this part of our loop, okay, we are constantly reducing that to 1, okay, so that this would get to terminate. So this is a very common scenario, okay, or use case for loops. Now, what will happen if, okay, you could not find a way to end that programmatically? Meaning, when I say programmatically, there is a code uh, that would enable, okay, that would enable the loop to terminate, okay, terminate or stop. So we have what we call, okay, an infinite loop, okay. So an infinite loop, as you can see here, okay, say this code, okay. There is a problem here. The problem is this is actually an infinite loop. Why? Okay, let's see. This this line, okay, so we have n is equal to 5. So we assign the value of 5 to n. Now here we test the value of n if it's greater than 0. So at this point, it's true. So if it's true, we're going to perform this print ladder and print rinse. After which, okay, it goes back here. Notice that there is no code here that would essentially change the value of n. Okay, n here would always be equal to 5, and 5 and 5 would always be greater than 0. That's why, okay, this would present an infinite loop. This statement here, okay, really would not have a chance to be executed, okay, since it would always perform this step. So if you're going to write this out, write this in code, Okay, so while n is greater than 0, print ladder print rinse. Okay, so this part here, line 5, would not be executed with this type of code or with this code. Okay, oh, this is very similar. I think this is like a program for laundry. Okay, laundry washing. So ladder rinse. Okay, but this is an infinite loop since again there's no means for us to end this programmatically since it would always have the value of n equal to 5, then 5 is always greater than 0 and gets to execute this. Okay, so if you're going to run this, you'll see, okay, so that is an infinite loop. Okay, it would continue to do so until your memory will be consumed. So if you want to stop that, just press Control. Okay, so either your IDE would bug or would crash. Okay, or if you could make it, you could press Control C. Okay, but since this has been the case, okay, see this is already a crashed application. So I'm going to close this. Okay, now you do not want this to happen. Okay, since you might have encountered programs in which they crashed in the middle of a runtime execution. Okay, so that is an example of a critical error. Okay, so now I'll be opening IDLE again since the program itself has crashed due to that infinite loop. Okay, so going to open that again. Okay, so that's the problem here. There is no means for us to end this programmatically. Okay, so that is an infinite loop. Now, in this example, okay, we change the initial value of n, okay, we change the initial value of n here, okay, to 0. Okay, what would be the problem here? Okay, the problem here is this loop would not have a chance to execute. Okay, it's like a contrast, okay, or the opposite of our previous example, which is an infinite loop. In this case, the loop would not execute. Why? Since n is equal to 0, and upon testing, upon checking at this point, n greater than 0, 0 is not greater than 0. So what will happen is these lines under our loop would not be executed. Instead, it would move outside that loop or proceed to the statements after that loop, okay, which is dry up. So if you're going to code this, we just change this to 0, okay, going to save and run this. So you get to see, okay, this part or our loop didn't execute, okay? So that's that. So breaking out of a loop, okay? Now, a break statement ends the current loop and jumps to the statement immediately following the loop. What does it mean? Okay, break a break statement is used to move outside a loop. Okay, meaning it would stop performing that loop and gets to execute statements that are written after that loop. Okay, so it is a loop. It is like a loop test that can happen anywhere in the body of our loop. So for example, in this code, so we'll write it here, okay, while true. Now you might be saying, sir, is it that the case that this would become an infinite loop? Yes, it is possible if you do not have a means for it to end it programmatically. But later on, we'll get to use the break statement so that we get to move outside of the loop without even going back in this statement here. Okay? Remember what I have discussed earlier in which, okay, usually the loop, uh, a while loop, okay, starts with with testing a condition and ends with testing a condition. But using a statement like a break statement would, okay, would disrupt that or would change that behavior in a manner that it would immediately go outside the loop. Okay? So let's say while true, line is equal to input. So this is just a line that would accept a user input, okay, with this as our prompt. So if line is equal to done. Now, if the user would really write the word done, okay, case by case, letter by letter, okay, it would, okay, it would break, meaning it would move outside of our loop, okay? If it's not, then, okay, so if that is not the case, then it would just print our line, okay? So let's say I'm going to write here finish, okay? So again, so what this will do, okay? While true, okay, normally this would repeat indefinitely, okay? By the way, we'll discuss indefinite loops later, but okay, let's just have a preview of what an indefinite loop is. An indefinite loop usually use a while loop since uh, when we say indefinite, we do not know when the loop would stop. Okay, we do not know the exact number of iteration that it would stop. Actually, our first example earlier in which it counted down, okay, we could say that that is a definite loop, since we know for a fact that after a certain number of execution in code, we have written that explicitly in code, okay, we know that it would execute, let's say, 5 or 6 times, okay? But here, okay, it would stop, okay? Indefinite is not the same with infinite, okay? So when we say indefinite loop, okay, there is a means for it to programmatically stop, okay, upon runtime. But in infinite loop, there is no means for it to programmatically stop either with your code or during runtime. Okay? So going back, now if the text that the string that you have entered is equal to done, then it would break. Okay? A break statement would disregard the rest of the lines here, then move outside and move to the statements, okay, that are outside this loop. Okay, so we could say uh, lines 1 to 7 is our entire loop. Once the break statement is executed, okay, it would move to the lines outside of this 1 to 7, okay, which is this line here. So if you're going to run this, okay, at this point, it's waiting for us to enter, okay, so this is the prompt. If we're going to write here hello, okay, since hello is not equal to done, okay, this would not be executed. Okay, this is a one-way decision. So it would perform this. So if we're going to enter this, it would print the line. Okay. Then, since this is our last statement in our loop, it would move back here. Now, since this would always equates to true, since while true, okay, really there's no test condition here, it would always evaluate, okay, irregardless. Okay, so it gets to ask again. Okay, ask again. So let's say if I'm going to write here world, still it's not the same with our text done, so it would print that. So if you write the word, let's say capital letter D, O, N, E, what is the output? Okay, the output is it would still print that text since this is case sensitive. Okay, capital D is not the same with small letter d. Okay, so this would actually result to false if you are going to compare that here. But if we're going to write the word small letter d, O, N, E, Then it gets to execute the break statement that then we would expect that the print finish would be executed, then it would end the program. Okay, as you can see here, okay, this indicator specifies that our program has been finished. Okay, so that is the break statement, commonly used for indefinite loops. Okay, or meaning execution or termination of the loop is determined usually during runtime. Okay, in this case, upon user input. So if we have a break statement, we also have what we call our continue statement. The continue statement ends the current iteration and jump to the top of the loop and start the next iteration. Okay? It's it's not the same with break. Okay? Though it is similar in a way that it changes the flow of our loop, but it's not the same. Okay? Its behavior is not the same. Okay? So let's go that here. So let's say, okay, this code, maybe line, okay, so we only need to add a new if here. If line, okay, this might be new to you, but let's just discuss this shortly, okay? Okay, I think that's the line that has been added. Okay, now you might have noticed that there is an additional part of our line. Then there is this square bracket with a zero in it. Okay, this is actually this is what we call indexing in strings. Okay, now strings are actually we could refer to strings as a collection of characters, and each of that characters has an index for that string. Now, an index is like an assignment of that string, and it's assigned character by character. Let's say for the character done. Okay, it is actually indexed from 0 up to so its index is 0, 1, 2, 3. Okay, so 0 here is used to access the first character. Now we could actually use this if we're going to comment this. Let's say if you will be tasked to get the, let's say a common application of this is getting the middle initial given a middle name. Okay, usually the middle initial is the first character of that middle name. So let's say we have middle name is equal to input, okay, enter middle name. Okay, so how are we going to get the middle initial? So let's say mi. So mi is equal to middle name, okay, then if you want to access the first character, so you're going to write this, okay. If you're going to print that, let's say print middle initial, okay. So mi. Again, this has been commented out. Okay. So let's just check if what this code would do. I'm going to save this. Okay. So I'm going to write here, let's say cruise. Okay. Now upon entering, since in this point of our code, part of our code, we only access the first character of that supposed first character of that middle name, so we're going to expect the what? What would be the printout? It would be middle initial C. Okay? So that is this purpose here. What's the purpose of this part of your uh, let's say code or variable? So with that, okay, what this will do is it behaves similar to how comments are treated or number signs are treated as comments by Python. Okay, remember, if you want to use a comment in Python, you usually start with a number sign, then comment. Meaning, when you enter, so in this code, okay, if you were, if the text that you have entered starts with, okay, a number sign, it would, okay, continue. Continue, okay, what this will do is it would go back, okay, it would go back here, okay, it would go back to the first, okay, to the first part of our loop, okay. So the continue statement ends and jumps to the top of the loop and start the next iteration, okay. So what this will do is, if it gets to encounter this, then it will issue a continue statement, then it would go back here, okay. So if it gets to see the first character of the text that you've entered has a number sign in it, it would ask the input again. Now if it's not, then going back to our previous example, okay, as long as it's not done, okay, it would print that line. If it's done, okay, then it would break, it would go outside of our loop. Okay, so for continue, it go back here. Okay, for break, it ends here. Okay, so if we're going to run this, let's create a new shell. Okay, so if we're going to write hello, so it would print that. But if I'm going to write number sign, then hello, okay, you'll see it go back, or it went back to this part here. So as long as I do that, okay, having this first character as, okay, as our in our text, okay, it would ask for our user input. Okay, so world print hi, it's going to print that. If I'm going to write the word done, then this will be executed, then it would move to this line here. Okay, essentially ending our program. Okay, so that is continue. So again, indefinite loops, we usually use while loops, okay, because they keep going until a logical condition becomes false, okay. So the loops we have seen so far are pretty easy to examine to see if they will terminate or not, or if they will be infinite loop. Okay, again, infinite loop is not the same with indefinite loop, since infinite loop is considered as a programming error, okay. It doesn't have a means to end programmatically, okay. Whereas an indefinite loop, okay, the number of iteration is not determined, but it would eventually end given a condition during runtime that it gets to terminate it, either by a condition or either by a break statement. Okay. Now we also have definite loops. Okay. Though we have used while loop earlier in our first example to perform a loop that executes definitely or an exact number of times, but in this case, okay, we usually use what we call a for loop. Now, oftentimes we have a list of items, okay, that we iterate across through. So an example is a lines in a file, okay. So, Ana. Okay, so we can write a loop to run the loop once for each of the items in a set using the Python for construct. So these loops are called definite loops because they execute an exact number of times. So we say that definite loops iterate through the members of a set. So here we have is a list. Okay, a list is similar to a variable in a way that they both contain data. But a list is different since it could contain multiple amounts of data. Okay, so we'll see later how we get to treat this like a variable. But in this case, we could say that this is a list literal. So what this code will do is I here, this is our iteration variable. Okay? We commonly use I as an iteration variable for an arbitrary set of numbers. Okay? Or an arbitrary list. So in this case, I here would iterate. Okay, it gets to iterate across all or each member of this set or in this list. Okay, they are separated by comma. As you can see here, it is listed 5, 4, 3, 2, 1. Okay, so what this will do, how it will perform is like this. Okay, for I in this list. So naturally, it would, okay, or technically, it would start with the first item in that list. If you get to see that there is that item or there is still an item that should be checked, it gets to proceed to this statement. Okay. After that, it moves outside. It moves back here. Okay. So for I in this list, since 5 has already been iterated, so it proceeds to the next item, which is again these are separated by commas. Okay, which is 4. So since there is still that item that needs to be checked, okay, so it gets to print that. So this gets to continue, okay, until there's no longer an item that would be checked. So if I is it's checking on 1, okay, so it would print 1. But since upon going back, okay, since there are no longer items that are available for checking, so it would move outside of this uh, of the loop here, then it gets to print, okay, statements that are outside that loop, okay. As you can see here, it's very similar to our first example, but we have achieved that with just 3 lines of code, okay. So that's it. That is a definite loop. Now, as I mentioned earlier, okay, list, okay, a list is a container of multiple data, okay. Now we could also, okay, but before that, let's try and write this into code. So for I in, okay, so we use square bracket, okay, similar to index, but remember the use case is different. We are using this as a container of our list, but actually, okay, list is also index, but since that is outside of our, we'll demonstrate shortly. Okay, I'll demonstrate shortly how using a for loop with a list is much preferred than doing this manually. Okay, so let's say 5, 4, 3, 2, 1. Okay, actually it doesn't really matter if you arrange this in order or not. Okay, so we'll see. I'll modify this later so that you get to have an idea how a list would or how a for loop would behave while iterating through a list. Okay, so we're going to run this. So you get to see, you get to have that output. Okay. Now, what I meant earlier is, let's say if I'm going to change it to 4, then change it to 2, okay, 13, okay. The order doesn't really matter since how this iterating variable would access the list is it would go through each from left to right. Okay. So if you're going to run this, expect the same order of items to be printed out. Okay. So run. So get to see here. Okay. It is printed as if of the same order of that list. Okay? Now, we could actually, okay, create, or we could actually assign this, okay, to a variable. Okay? So let's say numbers. So we could copy this, then instead of writing this, we could use this as in our part here, okay, numbers. So it would achieve the same output. Okay? Now, how you're going to access a list, okay, without doing this, okay, you are going to use, we are also going to use indexing here, similar to our string, okay, diba? Earlier, I have mentioned that a string, let's say in this example, it starts with 0 and ends with the total number of strings, characters minus 1. Okay, what I meant by that is, okay, how many characters in this string? So if we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Since there are 9 characters in this string, it is indexed from 0 to 8. Meaning it starts with 0 instead of 1. Okay? So, to prove to you, we simply count that continuously. 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is similar to list. Okay? They are indexed in the same manner, though they are separated by commas. Okay? So we could say that this is index 0, 1, 2, 3, 4. But how are you going to access this individually? Okay? So you can actually access this individually by writing. Okay? Similar to what we have done earlier. Okay? Sa line brackets 0. Okay? So we're going to use this variable, okay, then the index. This might be, technically this is not part of our course, but since I have shown you a list, might as well show you some basic operation with it. Okay? So, without using a for loop, okay, let's erase that. If you want to access this individually, okay, what you're going to do is like this. Numbers, 0, okay? So we're going to print this out. Print. So this would access this first number here in our list. Okay? So we're going to do this how many times? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4. Okay? So as you can see, if you're going to run this, it is actually similar to our okay, previous output, but okay, we have done so manually. Now it's okay if we have this small amount of an item in our list, 5 items. So what if we have 20 items or we have 100 items? Okay. Now, though we could do this, but it's very cumbersome and loops are designed to perform this type of operation. Okay. So that is the importance of our loop. Okay. Now, a list could also, okay, the unique thing, okay, or the convenient of list are it could also contain strings. Okay, it could even contain different types of values at the same time. Okay, so let's say if we have here 2, okay, then 13.0, it could even contain boolean values. Okay, so this is a valid. Okay, uh, this is a valid list, okay? These are valid values of list in this variable here, okay? So if we could write the same, okay, for I in numbers, print I, so it would, okay, as you can see, it would print that without a problem. But do take note that these are of different data types, okay? Now, another example here is with strings, okay? In this case, we use with strings. So instead of numbers, let's say we have friends. Friends is Joseph. Let's say use another different set of person here. Juan, Pedro, and Maria. Okay. Now it's a very common syntax, or it's a convention. There's a convention in which, okay, when using a for loop, okay, the iterating variable is the singular form of this of the collection that you're iterating through. And of course, a collection should be named, okay, in plural form. Since if we're going to write it in code, it is much more understandable, okay, or it's more intuitive. So for friend in friends, okay, print. Let's say we're going to print friend. Again, this is our iterating variable, which changes every time our loop iterates. Then this is the collection that we are iterating through. Okay, so we're going to run that. As you can see, it printed those uh, items in our list. Okay, so in this example, we have, okay, since it's still not New Year, so let's say Merry Christmas. Okay, now, could say print and a Happy New Year. Oops, let's change that to capital. So what would happen here is it would somehow greet all of our friends individually, then print this last statement, okay, outside of our loop. Okay, Merry Christmas Juan, Merry Christmas Pedro, Merry Christmas Maria, and a Happy New Year. Okay, so what are some basic applications or use cases of loops? Okay, so let's say given the following loop or code. Okay, so let's just, okay, use this instead. Okay, 9, 41, 12, 3, 74, 15. Then let's say for number in numbers, okay, okay, this is just a slight modification on what we have here as an example. Okay, so again, what this will do is will iterate across this set here. Okay, so that. Now, if you're being asked, okay, how could you get the largest number, okay, given this item here or these items here? Now, in this short of an item or a small of an items, okay, uh, we could somehow find it quickly. Okay, if let's say mata-matahon lang nato. Okay, so we could say, okay, 74. But really, okay, a more, let's say, one way of doing this, okay, is what we call a linear search. Okay, or what this means is you are going to check item per item, okay, the numbers, and you keep track of the largest number. So it's like this, okay? So imagine you as an Python, you are the interpreter, okay? How you're going to view the numbers is you're going to access that number by number from left to right, okay? So, okay, first is it 3, 9. This should be, okay, somehow this has been interchanged, but anyway, okay, so let's say, uh, okay, let's use this instead. Okay, since this, I think this is the items that is being referred to in this part. Okay, so 3, diba? So when you are accessing this, okay, you keep track of what the largest number is. Okay, so accessing the first item, okay, you get to say that the largest number so far that you know of is 3, since that is our only number that we have viewed so far. It makes sense that the largest so far is 3. Next item, so we keep track of our largest. Okay, so let's say uh, largest is 3. So we're keeping track. Next is 41. Now since 41 is larger than our previous, okay, the largest number that we have been tracking, keeping track of. So we get to update that. Okay, with disregard 3, we now have a new largest. Okay, next item. Now, since 12 is not larger than our current largest, okay, so we disregard 12. Next, 9, still smaller than 41. We disregard 9. Now we have 74. Now, since 74 is larger than our current largest, okay, so we update our largest by 74. Then we move to next. 15. Still, now it's smaller than 74. Now, and since we no longer have any item to look into, we get to say that among the numbers that we have seen so far, essentially the contents of our list, okay, the largest number is 74. So how are we going to do that programmatically? Okay, so we can do so, okay, I'll just show you the code here, okay. So let's say if, okay, now we should have, okay, technically speaking, before we start iterating our collection, we don't have a current value of our largest. Meaning, we get to say that the current value of our largest does not still exist. Okay. Now, there are many ways to do this, but we could arrive with an assumption that, let's say, negative numbers are not included in this collection. Okay. Then we could write here a variable largest is equal to -1. Okay? Since regardless of what the first item here is, ultimately it would be the largest would be replaced by the first item that we have seen. Okay? We need to do this since we could not really perform something like this. Okay? If we haven't, if we don't have this part of our code, we are actually comparing the number here to a non-existent value. Okay? So if we're going to, okay, we're going to continue this. Okay? Let's work with the correct version of our code. So if number is largest, meaning if our number here is greater than the largest number that we have been keeping track of, we are going to update the value of our largest to that number. Take note how data is what the movement of data is when we talk about assignment operator is from right to left. Okay, so this is assigning the value of number here to a variable largest, essentially, okay, or technically updating this value here. If that is not the case, then we, okay, we move back here. Okay, actually this is all it takes for you to iterate our to our list, okay, and determine the largest. We could say print largest is largest number is largest. If we're going to run this, so you get to see here it printed out 74. Okay, since that is the largest indeed. So if you want, let's say if you want to modify this, let's say uh, if you want to print the number, okay, so run. So 341, largest number is 74. Okay, so that you get to have an idea, okay, or you get to have a basis in a form of output of the numbers that it is viewing. Okay, so that is the largest number. Now, if you're going to omit this, okay, this would cause an error on the first iteration. Okay, as you can see here, largest is not defined, meaning at this point, at the first, this happened really at the first iteration, okay, it doesn't have a value to compare to. Remember, the first iteration would refer to an initial value. Second, to the last iteration, it refers to the iteration variable. Okay, essentially, still we refer to the initial value as the iterating variable. Okay, but in this case, it based its value, okay, on this initial assumption that the largest is a negative value. Okay, so I hope you get the idea how this is done. So next is, okay, counting. Okay, it's very easy to count. Let's say let's revise this. Okay, counting really is, okay. You could use a counter variable to keep track of the current iteration. Okay, so we simply write. Okay, we have here a counter variable set to 0. Okay, so that we could then, let's say, perform this step. Count is equal to count plus 1. Print count. As you can see, even though, okay, number here, we didn't really use this as part of our code here. But how a for loop works is it would iterate using an iterating variable through a list. So you still need to do this even though you only need to count. Okay? And how are you going to count? Really, you are just, every time the loop iterates, you simply increase the current value of count by 1. Okay? So plus 1, plus 1, plus 1. Okay? So you'll get to expect that this would have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? 6 count. So, instead of doing this, let's, okay. Doing it like this will allow you to see the counter variable being printed out per iteration. Okay? So run module. So you get to see 1, 2, 3, 4, 5, 6. But if you're only concerned of, let's say, you only want to have an output displaying the total number of items. So you should move that outside of our loop. Then we could say we have, if you're going to do that, okay, the output would be there's only one output, since as you can see here in our for loop there's no print statement there, okay, but we only have a statement in our last statement in our program. So run module, okay, we have 6 here. So to give more context about this, so let's say total items in list is, okay, like that. So if you're going to run this, na, okay, so that is count. By the way, uh, so far we have been using a list. Okay, so just I want you to introduce of a commonly used functions in when we talk about list. When we talk about iteration, okay, or looping statement, is the range function. Okay, so let's say, so let's move back a bit in our discussion since I have skipped this part. Okay, diba? So this is similar to counting from 1 to 6. And let's say for number in numbers, okay, so it would print out 1 to 6, diba? Now, if your intent really is purely in counting, okay, if you are given a task to count from 1 to 100, though you could do this manually by writing the items individually, but there is a much better solution, okay? Instead of using a list, okay, remember, for loop is used to iterate across a collection. Now, a collection is not only limited to list, it is actually applicable to all uh, containers of data in Python, okay, that have multiple values. List is one, string is one. You could actually iterate across a string, okay. So we also have, okay, a range function. Now the range function would give you a number or a range of numbers, okay, based on, okay, the value that you specify here in its parameter, okay, meaning what you would supply here. Now, if we're going to put here, let's say 10, what do you think is the output is? Now, it might not be as what you expect, since the output given this code is actually from 0 to 9. It's like similar, it's like accessing an index. Okay, but if you want to, sir, I want to count from 1 to 10. Now, what you can do is you provide here an initial, okay, value separated by a comma. So now it would start by 1. So if you're going to run this, though it still ends with 9, but it did start with 1. So okay, we have solved this part here. But how do we solve the part here that it should not be a value less than 1? So with that, you simply, okay, add here a value. You only need to add, okay, 1 as our last value here. Okay, or what I mean is if you want to end by 10, you need to put here 11. Since as you could see, the behavior of this range function is it starts, so in this case, it starts from 1 and it ends from the last number, it ends at the specified number minus 1. If you're going to run this, okay, as you can see, it now starts from 1 and ends with 10. Now, going back to the solution, actually we have not used this list at all, okay, in this example. Okay, you can even erase this. Okay, going to run this. Okay, now, so if you want to print from 0 to 100, okay, you need only to write 1 to 101. Okay, so we're going to run this. So it would now count from 1 to 100. You just changing this portion here. Okay, so that is the range function. Okay, you might find this useful later on when you're working with loops. Okay, so going back to our counting example, let's say, okay, how about summing in a loop? Now, instead of counting, we want to sum. Okay, we want to perform, let's say, 3 plus 41 plus 12 plus 9 plus 74 plus 15. So, what we can do is, okay, we could create a variable here, let's say, sum. Now, let's have uh, sum num. Since sum, I think, as you can see, the color changed to something that is of a keyword. So let's say sum of uh, number, sum number. Okay, you could simply do something like this. Sum, let's change this to a shorter variable. Sum of is equals sum of plus number. So what this will do is, okay, on the first iteration, we have a sum of value of 0. Okay, at this point, sum of value is 0. So at this first iteration, okay, the number here is 3. Okay, so sum of is equal to 0 plus number, which is 3. So we have the sum of at the first iteration is equal to 3. Next is, for the second iteration, 41. So now we have, okay, 3 plus number, which is 41. Okay, so 3 plus 41 is 44. So now we have the new value of sum of as 44. So it gets to do that until we arrive with this last item here. So if we're going to run this, as you can see, we have 154. To check, let's see, uh, as much as possible, we would like to verify okay, our solution. So 3 plus 41 plus 12 plus 9 plus 74 plus 15. Okay, so 154, correct. Okay, if you want to print the numbers, you could simply write here print number. We get to have an idea, okay, of the numbers that we are summing up. Next is, okay, average. So in conjunction with the count and the sum, you can actually arrive at the average. Remember, how do you get the average? Okay, you need to get the sum of all the numbers, then you need to know how many numbers there are. So effectively, you make use of the count and the sum. Okay, so if we use count here, count is equal to 0. Okay, so count is equal to count plus 1. So we already demonstrated this earlier. At the end of our iteration, we'll have a final value of sum of here as the sum of these numbers here, and the final value of our count here as the last, okay, count of our item here. So we could say that the average, we could even write another variable here, average is equal to sum of divided by count. So we can now have average, yes, average. Okay, so the average is 25.666 and so on. Okay, so to verify so calculator, so we have 154, the previous printout, we haven't changed really the items, divided by 6. 1, 2, 3, 4. Yeah, 1, 2, 3, 4, 5, 6. Okay, divided by 6, so we should arrive with a similar answer. Okay, as you can see, more or less similar. Okay, even though we have 8 here, 7, but really that's a very small discrepancy. Okay, so that is your average. Finding average, filtering in a loop. Okay, so filtering in a loop, it's like you are filtering. Okay, you are limiting the printouts to a certain range of value. So in this example, let's say you only want to print, or you only want to recognize values or numbers larger than 20 as large numbers. So if we're going to change that here, so if let's say number, as we have used number here, is greater than 20, so we could print, let's say, large number. As you can see, it only printed 41 and 74 since those are the numbers that satisfy this condition, which are larger than 20. Okay, the rest are less than. So 3, 12, 9, and 15 are less than 20. Okay, so filtering using a Boolean variable. Okay, so this is just a flag that you could use to check if you have found a if you have found a certain item, okay, or not. So this is just a use case. So let's say found is equal to false. So initially you haven't found it yet, but let's say if value or if number is equal to 3, okay, we'll update the value of found to true. So if you're going to follow the exact example here, found, then number, okay, let's say this. So again, it's going to iterate through these items here it would initialize a Boolean, okay, a Boolean variable of a false value. If ever it gets to encounter the number 3 across its iteration, okay, let's change this to 9, 3, okay, it would assign a new value of found to the Boolean variable true. So if we're going to run this, you'll get to see this output. Okay, so let's check. The first iteration, okay, found is false. Now since 9, okay, the first iteration 9 is not equal to 3, so it gets to skip this, meaning it's going to print this out, which is, okay, false 9. Next, 41. Still the case, it's not equal to 3, so this doesn't change, so we have for false 41. The same with 12, false 12. Now here, since number is equal to 3, we're going the value of found here would now be updated to true. So the latest value of our variable found is now true. So we get to see true 3. Now you might be wondering, sir, nga no true gihapon dere, and dere is 74. Why is it still true here, even though the value of a number is 74? What happened here is, okay, so what I mentioned earlier, this is the most recent uh, assignment of our variable found, since it happened when it iterated when the number or when the item is 3. Now, even though 74 is not equal to 3, but since it underwent this iteration in which number is equal to 3, then it has been updated with the value of true. So you could found here would still be equal to true. Okay, then we have true 74 here. So the same with 15. Okay, so I hope you get the idea why that is the output. Okay, finding the smallest value. So I let you and I let you study that yourselves. It's very similar to largest value, but of course there are changes. Okay, to some operators. Okay, is and not. So this is used in conjunction with, okay, Python is an is operator that can be used in logical expression. Okay, it's the same as but not similar to equal sign. So SLAT also is a logical operator. Okay, so this is actually, okay, another solution in finding the smallest value. Okay, it's like a more correct solution. So again, I'll leave that to your understanding. Okay, so how are we going to apply this in our activity so far? Okay, so um, let's say, remember one of the examples that I have been using, always using is, let's say, square equations. Okay, so print square equations. Okay, say version 2. I think it's version 3 already, since we could say version 2 is when we were using conditional statement. But now, in addition with conditional statement, I will be using looping statement. Okay, so just a basic interface here. Okay, I'm in new. Okay, again, you already know this. Instead of numbers, let's say I'm going to use letters here. Let's say compute perimeter print b compute compute area, then print C for close. Okay, then option. At this point, I am still using conditional statement. Okay, so input, enter, an option. Okay, so if you want to be lenient in how the user will enter choices, let's say you want small letter A and capital letter A to be treated the same, in which it would accept that as the same thing. Okay. One solution, there are many solutions, but one solution is okay, using, remember, uh, if I haven't discussed with you logical or Boolean operators, okay, so there's actually a discussion with that in the original lecture discussion for or the older lecture discussion for this topic. Okay, but just as a recap, okay, when we have, let's say, okay, when or, okay, or behaves in this manner. Okay, T. Okay, now let me use a multi-line comment here. Okay, so T or T is equal to T, or true is equal to true. T or F is equal to F at true. F or P is equal to true if F or F is equal to false. Okay, so so P and P is equal to true. P and F is equal to false. Okay, P and F and P is equal to false. Okay, F and F is equal to false. Okay, what this means is when you are using or will I'll show you later. Okay, an or boolean operator, it only needs to have one of its operands to be true for it to ultimately have a value of true. Okay, as you can see here, as long as there is a two here, three p here for true, it would equate to true. Whereas in and, okay, it needs to have all of its operands to true in order for it to be true. If one of the operand is false, then automatically it would be false. Okay? So what I want is, in relation to that, is if option is equal to A, okay, we're using letters here, or option is equal to capital letter A. So now, every time the user input that whether A or A, okay, it would have the same branch, okay, or it would perform the same conditional statement, okay, or conditional statements, okay. So let's say side is equal to input enter side value, okay. But since this is a string, you need to cast this first, okay. Then we have, okay, say P is for perimeter is equal to side times 4. I think that's the answer or the equation. So print perimeter is, okay, P. Elif, okay, uh, option is equal to B, okay, or option is equal to capital letter B. Okay, let's copy this. So instead we use A here, then side the power of 2. So area, okay. Elif, you still need to take into account if it's C for close, C, or option is equal to C. You can simply write, let's say, print, thank you, then exit. Okay, so else, say current invalid option. Okay, so you're familiar with this. This is our one of our original. Okay, though some minor modification. Okay, remember, whenever we're going to run this program, it requires us to run it again after we choose any of our option here. Okay, especially in A and B. So let's say A. Okay, we're going to enter capital A. It would accept as if it is the same with small letter a. Okay, enter side value, let's say 4.5. You can see here parameter is being computed since that is our selection here. You'll notice that, okay, it would end our application. Now, if you want your application to continuously execute as long as the user wants to, then you can make use of a loop. Okay, so what we can do is we simply use, okay, we have seen this already, while true, colon. Now, since indentation is important, what you need to do is you just select all of this, then press tab, so that this would all be indented under this statement here. Now, as of this case, this would become an infinite loop. This would not end. We would like to end this, or we would like to have an option for the user to end this. So what we can do is, okay, we could write here, let's say, okay, could ask, let's say, again, input, do you want to try again? So yes or no. Okay, so you can simply write here if again is equal to yes, meaning you want to go back here. Okay, now remember what you want to do. If that is the case, if you want to go back here, you're going to write continue. If you want to end, meaning you want to, okay, you want to close, you want to move outside this current, this loop, okay, else, okay, or we could write L if, okay, then again is equal to N, okay. Here, we could either write two statement, okay, but we could actually write here break, okay. Remember what break does? Break would move, okay, would end the loop that it is currently being situated, it would move outside of that loop. Essentially, since there are no longer any statements here, okay, then it is as if it has ended our application. Okay, so if we're going to run this, okay, let's see. How about what if we click C? How does it behave? Okay, so exit, when you're using IDLE, it would actually kill the terminal. Okay, it would kill this shell. You're going to click OK. Okay, it closed that. But break would simply end the current execution of that program without closing the terminal. Okay, notice the reason is, okay, I have chosen C. I have used this, okay, statement. When do we get to have a chance to use this? Okay, when we choose the other options. So let's say A. So 5. Okay, as you can see, do you want to try again? Okay, so if I'm going to press yes, okay, it would go back to the first part of our loop, which is, okay, this part here, the printing of the menu. We're going to click yes, so you get to see here, okay, it loop back to our uh, menu. Okay, so if we're going to press B, capital letter B, so I want to compute the area. Let's say 4.56. So I have the area here. Okay, so let me see, is this correct? Side. Okay. There's a logic error. I've just noticed that now. Even though I have changed here in the formula, okay, I'm still referring to P here. So this should be A, okay? Sorry for that. Going back, if I want to choose B, 4.56, okay, so now you have this correct value. Just going to click no, okay, remember, N here would be issuing this break statement here. I'm going to run this to enter this value. As you can see here, with this 3 greater than symbol, it symbolizes that Python, okay, the shell has stopped executing the current this Python script. If you want that, okay, behavior, you can just change this to here, break. Or if you want, okay, that exit should be done here, so still just change accordingly. Okay, but if I want it to break instead, I do not want the ideally shell to be exited. So let's say if I'm going to click C here, okay, as you can see, it ended our application. Okay, so I guess that ends our topic with loops. Okay, definitely there are still more advanced applications of this. We still haven't discussed inner loop, okay, or nested loop, okay, loop within a loop. Okay, so we only demonstrated conditional statements, okay, in accordance together with loops. So that's it. So hopefully, this gives you a more uh, means of understanding our lecture material. Okay, so hopefully you get to have an idea on how this will work, and please do apply this. Okay, it's not enough that you merely just watch this video. Please take time and try things out. Okay, so that's it.